Welcome to the Neural Implant Podcast, where we talk with the people behind the current events and breakthroughs in brain implants in an understandable way, helping bring together various fields involved in neuroprosthetics. Here is your host, Ladan.
Hello, everyone, and welcome to the Neural Implant Podcast. Now, this is one of a series of 3 poster sessions that I was able to record at the NER Conference, which is the Neural Engineering. I actually don't know what the R stands for. Nobody ever told me. So this was on the 20th to 23rd of March, 2019 in San Francisco. Really good time. IEEE EMBS Conference on Neural Engineering. Very cool stuff. And unfortunately, I only did the poster session. I only recorded the poster session on the second day, so I only got half of it, and I only pulled out the recording equipment in the end. So I actually saw a lot more really cool pipers that I would have loved to feature here, but they might have been cleaning up or very busy by the time I came around, or it might have been the second day. So hopefully you enjoy this, and hopefully I'll be able to bring you more of these in the future because these are really fun.
Do you want to introduce yourself?
Yeah, I'm Ian Baumgart from the University of Wisconsin-Madison. I work with Kip Ludwig and his neural engineering lab.
Okay, very cool. And do you want to talk about your project, title of the project, and what you did?
Sure. So it has a very long title, but essentially the product we're unveiling, this is kind of the debut, is the Injectrode, which is a novel biomaterial for neural interfaces. It's essentially a liquid pre-polymer that has mixed in conductive particles that's fully injectable. So it's a minimally invasive procedure and conforms around the target nerve of interest. This is for peripheral nerve interfaces, and then cures in vivo so that you can stimulate to something like a nerve cuff.
So you inject this electrode basically and goes around the nerve. Does it find the nerve or does it just polymerize wherever?
So it kind of polymerizes wherever. Right now we're leveraging a lot of surgical competence, but at some point we're going to kind of develop the surgical procedure some more and really nail down this delivery mechanism so that we have something that's easy to administer and hopefully help a lot of people.
Okay, and so what are the results of this poster? And be sure to describe it because our listeners are not able to see what we're seeing.
Sure, fair enough. So essentially, we set this up in kind of a standard chemical testing setup with 3 electrodes with a platinum counter electrode and silver chloride reference for those of you interested. And we conducted cyclic voltammetry, which kind of assesses the Faradaic reactions occurring at the neural interface between the Injectrode and wire. Right now, we're using silver for both just as a proof of concept. Eventually, we'll move on to the more expensive materials, but for now, just silver. And we saw remarkably similar characteristics between the two. Similar charge injection mechanisms, similar charge storage capacities, and similar trends in the voltage transient analysis, which we also conducted. Unfortunately, silver is not a good metal for neural stimulation since it has so many Faradaic reactions, but we got something comparable, which is kind of what we were aiming for. And this was all kind of consistent with just a shift in impedance, which we kind of confirmed with our electrochemical impedance spectroscopy. And that's kind of the summary, is that they're not that different between the wire and the Injectrode material.
Okay, cool. So what would be some of the advantages of this? Like, why is this better than maybe some other methods?
Yeah, definitely. So we're really stressing kind of the minimally invasive procedure. It should just be able to be delivered even in deep structures with a syringe and catheter or a syringe and needle for whatever structure you want. And we've developed a method for non-invasive interface, so you actually don't have to have the current source implanted, but you can use a TENS device, transcutaneous electrical neural stimulation, that is, to actually deliver current to the target nerve. So that's really exciting. It's also somewhat softer material. It's more compliant. That all aids to biocompatibility as well as the conformal nature. So since it's injected as a liquid, it's going to conform to whatever neural structures are there, such as even complex structures. We've done some tests on the brachial plexus, which is kind of a jumble of noodles, but we still get a good target activation.
Okay. Yeah, very cool. And what are the material properties of this? I think you guys said you haven't really worked on this so much yet.
Yeah, so the physical properties have yet to be characterized. We're also interested in doing modeling of kind of it is a porous structure, or it is a porous material, and we're interested in doing modeling and testing on the kind of diffusion and fluid ingress into the bulk of the Injectrode, and then, as well as the physical properties such as different moduli for strain, stress, and the fluid moduli.
So what are some next steps for this work?
Next steps. One big one that I've gotten a lot of questions on today has been the installation of the Injectrode device. Right now, we've only been doing acute studies with no insulation essentially around the Injectrode material. We do need to make that happen at some point so that we're not delivering current everywhere in the body where the Injectrode wire touches. So that's one step, a lot of kind of processing and how to make this a commercially viable device that has a long enough shelf life. Right now, we're looking at hours rather than weeks. So we'd like to change that, as well as more characterization and more, studies on just proof of concept at this point, and also getting to those more appropriate neural interface materials such as gold, platinum, things like that.
Sounds good. This is really cool stuff. I really enjoy it. Is there anything that we didn't cover that you still want to mention?
The paper is out there on bioRxiv right now and is being submitted to publication soon. So be sure to follow up on that. I guess the best way to do that would be to search the PIs, those Manfred Frank, Andrew Schafstall, and Kip Ludwig. Well, actually, let me give you the paper. A truly injectable neural stimulation electrode made from an in-body curing polymer / metal composite.
Sounds good. Thank you so much.
Great. Thanks a lot. Appreciate it.
Hope you enjoyed the show and were able to learn something new, bringing together different fields in novel ways. Until next time on the Neural Implant Podcast.